Hey everyone, welcome to our CS61B Project 3 showcase. And so this project is basically your first construct a world, and then you have like different tiles on the world. Each tile is 16 by 16 pixels, and you have an avatar which is your main character. So your avatar can step on the floor, and then it might fall off in the trap and die, and then it might caught up by a predator and being eaten, and it might just not going through the wall and like circle around the rooms. One thing that is really impressive in our code is that we, instead of creating a word that all people can see and all like you can see the whole world, we actually make the word move along with the main character. So the main character will always stay in the room, in the middle of the window, and then it also has a vision, so we can set the vision to, for example, 5 tiles or 10 tiles. So that's the farthest thing it can see. So before going to a very detailed coding or like detailed method introduction, I will first start off by introducing how do we construct the world. So the way we construct world is to first initialize the 2-dimensional tiles into nothing so that we can add stuff in. And then we define a class object called room. A room has its own width and height. So it might be a n by m sized room, and the boundary of the room will be wall. So each room was surrounded by walls, and then inside the walls there will be all floors. So that's how we initialized, as the picture shown, how we initialized all the rooms. And second of all, we need to merge the overlapping rooms. As you can see, some of the room might have like sharing the same wall. We don't want that happen. We don't want the main character to be isolated in the room. So we want to break through these rooms by implementing a merging algorithm. So basically what it does is to check if there is overlapping tiles between each rooms. If there is overlapping tiles, we want to break through these tiles and make all rooms connected. Make all the overlapped room connected. And then we employed a method called random walk. So the random walk will start at the room, and based on the random seed, it can go wherever it wants, like 4 directions, up, down, left, right. And then whenever it overlaps with the room, it will create a merging path along while the random walk is walking. And then whenever it overlaps a room, it will connect this room. And by employing the random walk, we can actually make sure almost all the rooms are connected. And finally, we will do a breadth-first search to traverse all the room lists that we stored information beforehand. And then for those rooms that haven't yet been connected with the main part of the room, we will actually make those rooms connected by using the BFS. So this is the room that we generate after using the random seed. So it has some rooms, some corridors, some pathways, and by the way, the random walk will end whenever it hits the boundary of the world. So whenever it hits the boundary, it will create a layer of wall to make sure that all the rooms and corridors are enclosed. The second part of this showcase will be try to see the dynamic movements of the world. So as you can see, this is our manual page. We have our title, and we name this name the game. And then we have several options. We can either create a new game or load game or quit. So quit here would be different from the quit in the game. In the game, we will press quit in order to quit to the menu. But this quit here, we will just directly call system.exit to exit the window. So why not we start with a new game? So we can press N, and it will shows up enter a seed and press S after finish. And let's type in 256S. So it will generate a world with totally random tiles. And as what I just mentioned, it has specific length of vision. And because we implement based on the physical law, that the light move in a straight line. So all the vision the character has was straight line surrounded by the main character, the avatar. Whenever the light hit the wall, the light will stop because the characters can't see through the wall. So this is kind of the character's vision right now. And then we also implement the movement, so the character can move up, down, left, right based on WSAD, and then it can't pass through the wall. As you can see, I'm pressing going to front, it can't go through the wall. And one thing notice that the character we assume that the corner of the room, a corner of two walls are also can be seen through. So that one thing is that we can like make it more reasonable physically, and then we can also give the users more information while playing through the game, so it'll be more fun. And then we actually also have a creature called Predator, so it will be a red dot, and we're trying to find the Predator. Here it goes. So the Predator is employed using A-star algorithm, and it will try to catch you, and based on the distance between you and the main and the predator, and you are trying not to be catched, try to be caught by the predator, and the predator moves one step every second, and it will refresh whenever you move. It will render the frame, and once you are caught by the predator, the game will end because you are dead. The way we implement a teleport, which is a portal. So I just changed some parameters to make 20 portals in order for the showcase and performance to be better. So let's run this program. And as usual, we can press N to start a new game. And let's do the same thing to control the variable 256 and press S. So we will be in this same game because we are like using the same random seed, pseudo random seed actually. So as we can see, here's a portal, and once you step into a portal, it will create another world, and there's a predator chasing us. Let's flee away. So there will be so as you can see, whenever we use the portal, we will enter a different world, and feel free to move along. And it is also still employing the pseudo random object because we're passing the we are creating a new world. We use the seed of this random object to create a new random object, so the random object will follow along. We also implement another types of things in our world. It is a trap. So I just changed the parameter of the trap to 30, so there will be more trap in the world, so it's more obvious for us to see the trap. So as usual, we will type in 256 and S controls the variable, so we will born at the same place. And here is a trap right next to our born place. And what traps does is whenever a character step into the trap, it will die immediately because the trap kills people. So let's just try to step in, and we died. That's it. That I want to highlight in our code is that we, instead of create a whole world that the users can explicitly see what's going on everywhere in the world, we make it implicit that users can only see a specific vision. As what I mentioned before, the windows move along with the main characters. So we set up the specific line of sight, so the characters only knows limited amount of information. So it brings more uncertainties for users, and as a software engineering, presumably in the future, we always want to improve and enhance users' performance on the game. So this would create more uncertainties, and the user would be more enjoyable in exploring the new world. Okay, so last of all, we also make a different tile called swamp. So the mechanism of swamp is basically if you step into the swamp, it will be like 50 milliseconds delay. So like you were stuck in the swamp. Oh, it's actually 500 milliseconds, but it doesn't matter. Okay, so let's start a new game and see what will happen. So let's just type in some random seed, and then as you can see, these two double dash line are the swap, and then once you hit on it, you will just stuck inside for half seconds, and then it also works for multiple layers or like multiple consecutive swamp. And some difference between this swamp with other tiles is that we have to trigger that before we record the avatar's movement, because we want the avatar to first step into the swamp and then it can't get out of the swamp. So that's a subtle difference.